Goodness. Done.
Hi, Chris.
Hey, I can hear you. Can you hear me?
I can hear you just fine.
Awesome. Excellent. How are you doing?
Good, good. How are you today?
I'm well. We are early. So
Yes.
I just I had to make sure I updated it and all of the usual Zoom encumbrances.
Yeah. Never expect them.
Yeah, it's always like you go to start the thing and it's like, oh hey, you got to do an update. And it's like, oh sorry.
No, it's okay. Let me go ahead and share my screen here.
We're gonna wait a few minutes to make sure we let everyone else. I've got another person gonna join to help do some of the review. Um, so feel free to share your screen, but we're not gonna talk about anything for another 5 minutes or so.
Sure. Okay. That
Let
sounds
every.
fun.
I don't. Do you have other people from your team coming?
Yes. We have some right here with me in the
Okay.
lab.
Yeah. So 5 minutes. We got. You got room. You got room to if you need to use it, go now. Shake the dew off your lily, whatever. Final prep.
Thank you. Thank you. You want to get Brandon's camera? You have some money? No.
All right, guys, I think someone else may join us here in a little bit, but if we want to get started.
Sure.
So, how's it going?
Great, great. How are you?
I'm well. How long have you been involved in Rockets?
So our club has started, was it 2015?
2015.
We were founded in 2015. Me personally, it's been about 3 years since I've got into Rockets. I'm the team captain currently for the rocket launchers here at UTRGV.
Okay, awesome. And so, have you flown at Spaceport before successfully?
Semi-successfully.
What does that mean?
So years prior, there was a team, or one of our previous teams, they did successfully fly and recover. It was 10K COTS. And last year was the most recent team that went out there since the COVID era. So we had a great launch. Unfortunately, though, our drogue seemed to have tangled at Apogee. And so we came down 70 miles per hour, and our main didn't deploy either.
Ooh, hard
Yeah.
landing, huh?
Hard landing.
Hard landing. All
So-
right. So, I bet you got some lessons learned from that.
Definitely. Yes.
All right.
Definitely.
All right.
So,
So what do you got to show me? Let me kind of go real quick over sort of the highlights of what I think I need to ask about.
Sure.
I'm going to ask you things like, is the rocket build complete? And then do you have pictures of it, or can you show me parts of it? That's one thing. Ground testing. So interesting that you should mention that you had trouble recovering. One of the things that I typically, me personally, like to see the teams do is show up with having packed their entire parachute, harness, all of the things, and done a ground test, and then video that and show us that that worked well, right? Shear pins, all that kind of stuff. That'll come into play, right? Like how many shear pins, because what also happens is folks will fly and they don't have enough shear pins, and they'll put the main out up at Apogee. So if you don't have it, this is why we may want to look at some of those rocket parts, especially the connection for the aviation bays and where the parachutes are, so that we can see the types of shear pins, the quantities, the sizes, and et cetera, and then determine whether you might need more, which would then indicate additional testing to revalidate your black powder charges or whatever it is you're using. Okay.
all right. Okay.
And then the other thing that I'm going to be kind of pressing you guys for is hopefully you got a complete rocket, and I want you to run me through your simulations and any updates you've made to those based on reality, right? You design it and then you build it, and those things aren't necessarily always, perfectly aligned, right?
Right. Yeah. Okay.
Okay.
Sounds good. I think I need your permission to screen share.
Oh my! Now I have to figure out how to go do that. Where is it?
Oh, he has to go to host.
To the shield.
I
Yeah,
think
sure.
there's a shield on the bottom. It's a host.
Security. Yeah.
Allow participants to screen share.
Waiting room. Start video. It says allow participants to share screen.
Uh,
You want to share whiteboards? I'll let you do that.
I think he needs to go to participants, click on you, and then make you host. I think that was one way.
is that how?
There's another way to do it.
That's another way to do it.
If
That's
he
what
makes
I
you
said, yeah.
co-host the whole.
Maybe makes you co-host.
Uh, I hope that doesn't mess up the recording, but let's
You should be able to-
Should be good now.
There you go. There.
Right.
There you go.
All right. So is our full screen?
That's full screen over here. Sorry.
It's full screen. Okay.
Full enough.
All right. So let's see. I don't like that it goes that way. Let me remove this. Sorry. Huh. I guess I'll just go from here.
Okay.
So we're the rocket launchers, Team 107. We're from South Texas, University of Texas, Rio Grande Valley. And so this would be our sixth vehicle we've flown. I believe it's the sixth vehicle at Spaceport, right? Yeah. So there's a lot that's changed over the years. We've simplified our manufacturing processes, some big ones that we had. And we're looking to improve the recovery system, to have a full-flown test flight before Spaceport.
Uh,
And we're looking to place well this year.
all right.
So we can go to the next slide. So as I said, simplifying manufacturing processes, improve the quality, test. Oh, does it show on your screen?
I see the presentation, but I see the first slide, the rocket launchers.
You know how to fix technical difficulties.
Can you click on this? Oh no.
Let's see real quick.
It's showing your main screen, not the presentation.
Oh,
Okay. So,
Oh, you share. Oh, okay. You shared the editing part.
oops. Let me go ahead and end
yeah.
the
Okay, share again.
There you go. You got the goals. I see it. I see not switch back to the. It's okay. You can just click through. I think over there on the left side.
Yeah, there's it.
No. And then new share. You can start this one. Did you start the presentation on this one?
Yeah.
So start it. You need to share that screen. So go there, new share. Make sure you're sharing
No.
screen 2, which is that one. Do that one.
First screen.
Do you?
There you go.
There you go.
That's good. Okay. All right. Yeah. So goals: successful recovery, first test launch, and yeah. So I'm gonna go right into the structure sub team and present some things that we've completed so far.
Awesome.
Oh, is it? That's
Let's
not
see.
on this side. Oh, there you go. So structures. Last year structures had a really big issues with manufacturing as a whole. Our body tubes were actually made of blue tube, and we had to wrap carbon fiber over that. This year we wanted a high quality rocket, fully made out of composites. It's not that we've never done a fully composite body. We have. Our 2019 was actually fully composite. However, we actually didn't know how they actually manufactured it. So we had to learn from scratch. So this year, I decided to go on an adventure in how to like make an actual composite body fully. So it's actually made now out of half fiberglass and half carbon fiber. The reason why we did that is because we've always been really light. Our body tubes have always been really light. So last year, our body tubes were like maybe 4 pounds. This year they're 6.5 pounds. So we integrated fiberglass just to increase our weight, and the carbon fiber just to not be fully made of fiberglass, but to not be too heavy as well. So each body tube ranges around 6.5 pounds accurately.
Okay.
In terms of the fins, the system that we generated. Well, I don't know if you can see it here.
Yeah.
Is
It's a laminate.
exactly. So this laminate, this fin has an outline of wood that we've laser cut, and the inside is sandwich core foam, which we then laminated with carbon fiber. Then we did 6 layers of carbon fiber. The fin thickness is about 0.35, right, of inches. We designed it to be integrated into our center rings. So our center rings actually have slots in them, and they are used in combination with all threads. So what's essentially happening is that you're clamping the fins, and you're also straightening them out. We've always had issue aligning our fins straight, and since they were a tab system, last year, we didn't have anything to hold it correctly. And since epoxy doesn't cure really that quickly, then any little bump or shift can actually, move your fin. So this year we designed it to clamp down, and that's why you see the fin tabs extended forward.
Uh-huh.
And then once we clamped it and we had our center rings actually leveled, because of the you can manipulate the threads, the nuts, you can actually level your centering rings. So that's a bonus as well. Once that was done, we used Loctite nuts and Loctite nuts, as well as stop washers too, so that the nuts don't actually loosen up. After that, we were able to slot our fins into our bodies because they have a slot system. So we were able to slot them in, and we were put fillets on the inner body tube as well as fillets outside.
Okay. Do you guys see it, somebody waiting in the lobby?
Yes. Oh, there we go.
So this all in combination has made our fins really stiff. We plan on putting more fillets. We've had more fillets on there. As far as now, they're way more stiffer than last year's. Last year's was completely made of sandwich core foam. This year we just integrated a part of sandwich core foam.
Yeah. Okay.
Just
So,
so that
so
they're not too heavy.
you put these clamps together, you put your sort of your motor mount together, and then when you say fillets, so you're also then gluing your tube on top of that with fillets. Is that
So-
correct? Or are you putting fillets on this motor tube?
We're pulling fillets into the inner body tube as
Okay.
well. So all everything from the center rings to the nuts it's all JB welded with epoxy,
Okay.
so it's secured, and so
And heavy. And heavy.
yeah, and then heavy. So
Okay.
once we epoxied everything onto the body tubes themselves, we still had extra all threads that pop out, and it actually helps our thrust plate to be full in contact. So as we're
Uh-huh.
clamping down, it works in conjunction with our thrust plate, and then we ensure that there's contact between the thrust plate as well as the body tubes.
Nice. Okay. I mean,
Um,
I think I'm good with your fin attachment. It seems like you didn't use hot glue, so they're not just going to blow off in the wind.
No, we didn't use hot glue. We just used JB Weld epoxies. Everything is secured. I can guarantee.
Do you have
I can
pictures?
guarantee.
Yeah.
we
So
have-
I see your rocket back there assembled. Is it glued together at this point, or is it something that you can pull apart and we can actually look at the
it's set in stone.
set
We
in
can't
stone?
take-
Okay. Did you
set
take
in
any
stone.
pictures though? Did you take any
Yes.
pictures?
Yes.
We do have pictures.
So the aft end is JB welded, but you're still able to remove like your retainer cap and such.
Yeah. Right. Okay. Because it's bolted on. Right. I see the bolts.
Yes.
That's-
Right. Yes.
all right.
Photos.
It's not. Yeah. I trust you guys that this will be visually inspected at the site, but I haven't heard anything that tells me I need to worry.
Yeah, so-
I can attach some photos in the email as well. That way you're able to see this in more clarity.
Yeah, if you don't mind.
Okay.
there you go.
Sure.
Okay.
So
Darn late, guys. Can we start all over again? I'm just kidding.
So this year we're really secured on our fin attachment system. We believe the quality of our fins are much better than last year's. Hopefully test flight goes well. I doubt that if worst comes to worst, they'll break.
Got it.
If they do, we have a very efficient manufacturing method for our body tubes as well for our fins. So
So how
There's-
fast can you build another one if this goes sideways?
body tube, I can build 2 body tubes in a week.
Okay.
If we're pushing it, we can make a body tube as well as another coupler.
Okay. Well, let's move on to the other parts of the rocket then.
Hey, Chris, I had a real quick question for the team. You guys are meeting with Peter Tarl tomorrow, maybe?
Yes, sir.
yes, he's coming by to our lab tomorrow. Yes.
Oh, Lord bless you. Good luck with that. Yeah, that's Chris, I just want to let you know, I just found out about this last week, that Peter is doing I don't know, the guy travels like crazy, but he's doing Texas A&M and RGV. So the RGV guys also, I've been traveling down to Harlingen for probably the last 3 weeks. I've got another 3 or 4 weeks that I go down there on Monday, come home on Friday. But I have Friday mornings pretty much to myself. So I don't have to be at the airport in Harlingen until about 12 noon. So there's an opportunity if you guys are interested in me maybe swinging by and visiting with you guys and
Perfect.
checking it out.
Absolutely.
Absolutely.
That'd be
So
Cool.
make sure Peter does a good fin test on that fin can, because I'd like to hear his feedback on that.
Yeah.
absolutely.
I also do planning on doing a fin to fin layup. Peter pretty much walked me how to do it.
Okay.
We haven't done it yet, because the time constraints. We do plan on doing a test launch, but I do plan on reinforcing those fins as well,
Yeah.
as sturdy as they already are.
Nice.
They look
Yeah,
beefy.
I typically say if you can't hang, like you don't need to do a chin up on it, right? But hang 50 pounds on a fin and pull on it and see if it flexes, right? Like
Okay. Go to
Then
Yeah.
okay, go nose cone, or
go to
yeah, because let's move on.
okay.
So for propulsion system, we've used the M3400 for our past 2 competitions. And so one thing that I've noticed over the years is that we were just way too light for this highly impulsive motor. It would overshoot us
Oh,
2,000 feet, 20% of our apogee. So in relation to this new rocket, it is a lot heavier as you've seen. But we are looking to have a more accurate projected apogee because of that thrust to weight ratio. We're 10-1 currently. So I believe that it is a little more optimized for this system. Yeah.
okay. So the question becomes that we worry about is, do you have the motors, right? You say you're going to do a test flight. You've already got your motors. Okay. As long as your hands are on those motors, then I will worry a lot less.
We got both of them in December,
Okay.
I believe. Yeah.
All right.
So that's mostly it for M3400. Total impulse about 10,000. Max thrust about 4,000 newtons, and burn time is 3 seconds.
It's not max thrust, right? It's average thrust.
Well, yeah, the average thrust is 3421.
Gotcha. Okay.
So Chris, are you gonna be at the shootout, correct?
Yes.
And this is where you guys are doing your test launch.
Yes, sir.
So you're gonna get to play with the rocket yourself.
Oh.
You're gonna get to see it.
You're coming to the Texas shootout this weekend.
Yep, we'll be there. Yeah.
Oh, well, I'll see you.
Sounds good. Yes.
Awesome.
It'll be our first year testing. It'll be our first
Okay.
test launch.
Good.
Nice.
Excellent.
So,
Okay, what else?
Sure. So here we have the recovery system. I'll be filling in for our recovery lead.
All right.
So for this year, we'll be using for our mount at least, we'll be using an aluminum plate within the coupler that is using the Stratologger and Marshall 33. And for our deployment charges, we're using black powder FFFG. Primary is 8 grams and backup is 12 grams. We did do some testing on our previous build last year. After we saw that the main didn't deploy, we did a lot of deployment testing, and we were just playing around with it as much as we could, and we could see that we did need to increase our black powder deployment charge, at least on that build. So
have you ground tested this?
we are planning to ground test this tomorrow.
Okay. So
Yes.
take
That's fully
videos.
loaded
Take
with
videos. Yeah.
We'll do.
Take
Fully
that-
loaded. We got pretty much everything ready to go. Besides, we're using charge wells. We went and machined our own charge wells.
Do you have the pieces there? Can you hold them up to the
Yes.
camera?
Absolutely. So here we have our coupler. It's an 18-inch coupler.
Okay.
And then we have our charge rails here on the side. We're looking to reduce the height and increase the inner diameter just to save on some weight. But this
Well,
is just
actually, that's a way to make sure all the black powder ignites. A lot of people have a long skinny tube and they light the black powder and it pushes half of it out and doesn't ignite. So you need a larger diameter, shorter, and then make sure you pack it right with
Mhm.
wadding or something. Pack it tight. Okay.
And then
Well,
we have
8 and 12 grams will fill that up. So
Yeah, yeah.
that's a big
yes.
charge.
That's a big charge. So that was the other thing I was looking at. I was like, okay, well, those are big charge wells, so they're probably going to hold that 8 to 12. But before you cut anything off of that thing, you might want to make sure that the black powder all fits.
So I believe we fit, was it 15
grams.
15
Okay.
grams in this, yes.
Gotcha.
The volume for it.
All right.
So we have a U-bolt assembly with a swivel. These are all rated above 3,500 pounds.
Okay.
So we have a swivel and that goes to our main chute. I can go in and move this so you can see this slide. So I guess
Okay.
our disassembly portion. So we'll have a 2.2 CD main chute, 9 foot, and we have that parachute loop 10 foot away from the coupler. So it's a 40-foot shot cord tubular Kevlar, and it is 30 feet from the payload eye bolt.
Okay. So it's 40-foot tubular Kevlar, but the photo you have there does not look like tubular Kevlar.
Yes, so the photo that we have there is just a depiction of the knot that we're going to be
Alright.
making on the Kevlar itself. We have the
Okay. I
cord
know.
here.
I know a lot of people dislike knots because they say they reduce the total strength.
They reduce the strength on the loop.
Yeah, when you put knots in your Kevlar, that's or any rope kind of system, when you put knots in it, I think you lose you in theory you lose your you lose some of your strength. But if
Okay.
you're over far enough, and let me show that cord again closer a little bit.
Yes. Mhm.
Yeah, that's the big stuff, right?
Yeah.
Yeah.
1/2 inch tubular Kevlar is 40 feet long.
40 feet.
Yeah.
And that's the main harness. for
This is the main
parachute?
harness.
Okay.
Mhm.
And how long is your apogee, your drogue harness?
Our drogue is 35 feet.
Okay.
Yeah, you just want to make sure that how you line those things up, that when it's under your main and even potentially under your drogue, you don't have the two parts dangling.
want a
evenly
clacker.
smashing in. Yeah.
You know what a clacker is? It's an old toy.
A clacker.
It was a toy that you swung. It was these two little balls.
Oh,
back
okay,
and
okay.
forth.
Yeah.
Yeah. You don't want to make your rocket into a clacker.
Okay, that makes sense. Okay, so just give it enough space in between so that it doesn't.
Yeah, don't put your knot at the 20-foot mark where you've got two 20-foot, right? You offset it by 10 or 15 feet. Like give some room so that the parts when they're hanging by the parachute, they don't hit each other.
Okay.
Yeah, you don't want to inflict damage that's not incurred, during landing. So if it's smashing into each other on its way down, that's just that sucks.
Yeah, and you really don't want to do that on your test flight and then have to do repairs before you come to the spaceport.
Good point. Okay, that's be something to take into account.
Do
Can
you
bring
have?
the-
I'm sorry. Go ahead. You guys good?
No, yeah, I was
Yeah,
just bringing something this way.
All right. Do you have the sled that has the electronics on it?
We do have the sled.
And I'm curious, when you showed the electrical diagram, you showed the charges connected directly to your either the Stratolog or the what was it, Raven RC
Marsa.
Marsa. Okay.
So
How do you plan on connecting those wires?
So for this system, we're gonna have we have a hole that goes through the bulkhead itself, and
Okay.
that'll feed in through the deployment charge.
Okay.
And so what we'll have is the altimeters sitting on top. We have a rubber gasket that prevents it from touching this, and we also have nylon spacers that hold the altimeters here on top. So what we're planning on doing, one thing that we were thinking of doing actually is, for more redundancy, having 2 igniters lead into the charge well, so it just burns through everything. And it was just more redundancy in terms of making sure that all the black powder it properly burns through.
So
Um,
two igniters might not light. You
Yeah.
run
Yeah,
into you don't have enough amperage situation.
Okay.
So I would not do that.
Okay.
I would use a single altimeter with a single charge well for each end, right? The main and the drogue, or the drogue, hopefully the drogue first, then the main, right?
Right. Yes.
But yeah, I would use a single e-match for each of those operations, and don't try to put multiple e-matches. If you're really worried about redundancy, you add a third altimeter.
Makes sense. Okay. We do have the Blue Raven. Had some issues with it, but we're talking with the manufacturer and seeing how we can get that fixed. But
Okay.
as far as this, we'll be running these 2.
Well, and the reason I'm asking you about the way you're connecting those wires is I see a lot of people make very extravagant daisy chain hops with multiple connections, and I don't want to call them relay boxes, but junction blocks and things like that. And those are all failure points, right? And so if you're taking your e-match and you're bolting it straight to your actual altimeter that's doing the thing, and you're securing or blocking that hole that the e-match goes through your bulkhead, then that's the way I fly my rockets, because then there's the least number of connections and the fewest number of things to go wrong.
Okay.
Where does show me the hole, or does the
Sure.
e-match go in through the bottom of the charge
It
well?
goes
or
through
side?
right here. The wiring goes through this point here,
It's gonna be
Okay.
the other video.
and
Is it next to the charge well?
it is next to the charge well. Yes.
Okay, and then you make sure you get the e-match, the tip of the e-match, at the bottom of the charge well, right?
At the bottom. Yes.
Okay.
So the e-match will come up over the top edge and down into the charge well?
Yes. We're going to be drilling a hole into the charge
go.
well here,
Okay.
and it's going to go to.
Okay.
I got you. Okay. And from my standpoint, I've done that kind of stuff. You had mentioned, I guess, an O-ring or something like that. I just put hot glue on both sides.
Hot glue. You know what I use? I use modeler's clay, the
Yeah.
oily clay, the modeler's putty or whatever, the Play-Doh that doesn't dry out.
Yeah. You can also use a thick epoxy, anything like that, but put it on both sides, and you should not have any leakage at all.
Yep.
But the moment you do that, then that e-match has got to stay with that that thing, and that's fine. I mean, that's not that big a deal. What about your black powder? Are you just planning on dumping the black powder into the charge wells, or are you going to hold that in a small container or something?
So Peter had recommended that we were to use a glove tip and pour the black powder into the glove tip, and then fully secure that, so that way the whole charge burns itself.
Glove tip. Interesting. That would totally make sense if you had the e-match in the glove tip with all of that. Is that the plan?
Yes. So as we're gonna feed it through here, we're gonna also make sure that it's secured into the glove tip itself, and
Nice.
then that's going to burn.
Yeah, you're going to cut the fingers off of gloves and then put the e-match in, and then fill it, and then tie it off, and then shove it into the charge well, right?
Right. Yes.
Okay.
I'll say, because 12 grams, I mean, that's like 2 digits of your finger.
It's a thumb at least, right? A big thumb.
That's right. I mean,
That's quite a bit. Yeah. So yeah.
Just
So
be
we're
real-
going to be.
be real careful, guys. When you start messing around with, most of my 4-inch and 5-inch rockets, I'm playing around with 4 or 5 grams, that kind of stuff, and I still get really hesitant with that. When you start talking about 8 to 12 grams,
It's a big charge.
that could burn somebody significantly. And if it's packed into a relatively dense scenario like that, and somebody accidentally sends some static electricity the wrong way, whoo, you got some problems. So be careful with large charges like that. Wear your safety goggles, and whoever again is working with those energetics, those kind of folks. Do you have any L2, L3 people on the team, or is it who's your flyer record?
So our flyer record, his name is Ryan Grinnell. He's our L3. Currently here at the lab, we do not have L2 or L3.
Okay.
He will be meeting us at the competition.
All right. Just again, when you're working with the energetics, please be very, very careful. Make sure it's somebody who's triple E certified. At least you have a little bit of insurance there. But clear out the area. Make sure they've got the safety goggles on, maybe even gloves, that kind of stuff. Just be very, very. And then once that stuff is loaded in that rocket,
it's a loaded gun. That is a loaded gun. So where it's pointing and who's in front of it is very important.
Okay.
It's important to not be in front of it or behind.
Yes. Okay.
So, all right,
We'll
excellent.
do. Okay. On this.
All right. I'm good with that. Andy, any other questions there?
No, that's looking pretty good.
Yeah. Well, and then the 18-inch long, I like you got extra, you've got more than one caliber of coupler in your rocket.
I believe our current vehicle length is 123 inches. 123 inches.
So right at 12 feet.
Yes. So here's our telemetry system for now with our GPS. I'm going to pass it to our lead, Raymond.
Okay.
Hello.
Hello.
So my name's
Ham
Ray.
Who's the call? What's the call sign?
KI5VXN.
Okay.
Sir. So we're running two, I guess you could call them two telemetry computers here. We're running the ones being tracked by the mission control is going to be the Big Red B. It's a 100 milliwatt APRS transmitter from Big Red B. We've used it before. We've never had any problems with it. It's a great transmitter, except that it got crushed last year. But up until that point, it was transmitting, so we're happy with that.
So you have a new one, or?
Yes, we bought a new one. We got our hands on a new one, so we're good on that. And then our SRAT system that we're running is, I guess we named it TAS, or Telemetry Acquisition System. There's version 1, which you can see here on the right, which is this small chip, just a proof of concept that we could get the microcontroller actually working, and we successfully assembled it and got it working. So now we're on to version 2. Version 2, I'll touch on a little bit more in the other slides, but it is going to be using LoRa. We are working on version 3, which will hopefully use ham, but so far we're doing LoRa since it's the easiest one to work with. Protocol on that one, we're not going with anything standard, as that one's going to be our own thing. So we're probably going to figure that out later on down the line, but it's probably going to be something custom. We'd like to do APRS because I know you guys have, I guess, from what I understood, there was a limited capacity for LoRa tracking. So we're really pushing to get that ham one going. But for now, we like LoRa 915, so it'll be out of anybody's way. So
again, I don't think DaVinci's interested in tracking two computers or two transmitters from the same rocket. They barely have enough to cover the one. So
yeah, but Andy, I think they end up with, if these guys are trying to fly, they step on someone else's signal. Well,
it's very true, but from that standpoint, they're going to be assigned a specific frequency from that. But on your TAS, if you're going with your own custom frequency, that kind of stuff, and LoRa, who knows who you can potentially step on, etc.
APRS can be very limiting and inefficient. It's a lot of overhead for maybe not necessarily a lot of gain, right? If you're just putting a GPS coordinate in a packet and sending it, that's why it works really well in like a Big Red B. If you guys want to track other data and you're trying to get more real-time stuff, then you're probably going to want to use your own binary protocol.
No, that's definitely the reason we're probably going to go with a custom protocol. And also that we kind of chose with the 915 because I think as 915 was last year, I think it was kind of known as anybody could use it, but it's up to you whether you get interference. So we're going on that. We're still going on that, and that's why we're pushing for ham. Maybe hopefully next year, if not this year probably not, but hopefully next year we can get that our version 3 going with ham and maybe APRS. If not, if we can maybe work out something with mission control on a custom one, but probably if not, we'll just go with APRS on that one.
Okay.
But yeah, I'll move on here. So here's the iteration. Version 1, as I said, is basically a microcontroller close to the Raspberry Pi.
So is that little battery holder there the primary power for the device, or is it just a backup for the clock?
That is a backup for the onboard RTC, yeah, real-time clock. So
All right.
this whole system,
What direction are you gonna? What is the orientation of the mounting of this device in the rocket when it flies?
so this is going to be, since this little patch on the top right, the that one is actually the PA1616 GPS module from Adafruit. It's a self-contained GPS module that communicates over UART. So the orientation of this chip is going to be perfectly plane or parallel to the horizon, so that it's going to be that GPS will always be facing up, or well, as long as the rocket's facing up, you know. So yeah,
so I'm just worried about your battery.
Mhm.
So on that board in the middle, what is the orientation of that in flight?
That's going to be the battery is going to be, oh, here's the module. So the actual power source is going to be this external battery pack. This is a 10,000 milliwatt hour, I believe.
Got it.
So this will last us more than enough. So the module is going to sit up here on top. We're going to have flat. It's going to be powered over micro USB, and so we just plug that guy in, you know, and it'll go for as long as the battery pack obviously has power.
Okay.
But yeah, that's the plan on that.
All right. Those little batteries that are in that little holder,
Mhm.
if you mount it like upside down, when the rocket launches, it'll leave the battery behind.
Oh, okay. All right.
So you need to secure your batteries really well, all of them.
Mhm.
Right. The 9-volt batteries and whatever that are going to run your main flight computers, as well as the battery that you know, like just zip ties probably not enough. You need a shelf or some sort of support for it, right, underneath it. Yeah.
Yeah. So this will be mounted inside the nose. Let me pull this off real quick. So we have these little slots on here. So I don't know if you can see these little slots. So we're gonna run not only zip ties around it, but we're also gonna have double-sided tape to prevent any movement. So it'll be locked in there. It's not gonna go anywhere during the flight. And then the actual chip is gonna be, like I said, flat on here with standoffs on it screwed to the base. So yeah, the whole system will be pretty rigid onto this one entire board.
Does that go in the av bay or does that go in the nose cone?
The nose cone.
Okay.
Yeah, it's got the ring here. So it'll be bolted in. So it's got bolts all around.
What is your nose cone made out of?
Fiberglass.
Okay.
Careful, there's spots on it.
Yeah, it's completely made out of fiberglass, obviously to prevent the carbon fiber from, eating up the signal.
All right.
So yeah, that's the plan on that. Version 3, like I said, it's under development. This just goes through task 3.2 again. Some of the sensors that we're running, the pressure, humidity, accelerometer, or IMU, RTC, LoRa, GPS, all that stuff we're reading.
Nice.
Yeah.
So here's our nose cone. We just manufactured literally just yesterday, but currently doing some cosmetic work on it. But as far as it goes, yeah, it's made out of fiberglass, 8 layers, pretty sturdy. In terms of the nose cone tip and mount, we have our mount. Our nose cone tip is coming in today, so we're pretty secure on that in terms of nose cone.
Excellent. Okay.
And yeah, I believe that's everything from my side. Do you guys have any questions for, I guess, me before I hand it off to Payload?
I have no further questions there.
All right. Then Payload.
Hello. All right. So for payload, it will not deploy. I'm pretty sure that's the main question y'all have for safety. But basically, we're gonna do 3 tests. This semester, I'm actually graduating, so I want to leave behind, guess, a foundation of payload because that's kind of where we're weak in the competition. So these 3 payloads are going to be, well, we have payload 1. We're going to have the data acquisition system. It's almost the same thing as telemetry, but what we want to, I guess, acquire is the data that every other payload is going to be getting. So we're going to try and use ESP32s on the inside, and just so they can communicate with each other. Payload 2 is going to be, it's called the ultimate egg drop. We're not going to put an egg, but we'll have a sensor in the inside to try and figure out how much we're damping. So we're going to do a dampening test with magnetorological fluid. So we're going to make our own damper on the inside and try and control it from there. I have we tried synthesizing. We tried synthesizing our own magnetorological fluid, but it failed. So we're probably gonna buy some, but we're still gonna keep on trying to make our own formula. For the third one, it's called Ice Age. We wanted to put ice in there, but we don't have the battery power to keep it alive at the desert all day. So we're basically going to be using TEX in there, which is forgot the acronym. Thermoelectric coolers, using the Peltier modules, and we're going to see how good we can get there, basically.
How good of an ice chest you can build, huh?
Yeah, basically. In case we wanted to do some sort of biology experiment somewhere in the future, we have some ground testing in the future. So I'm just basically laying a foundation this year. This is some of the design for our CubeSat. Everything's going to be in CubeSat format, and this is the backup. In case it doesn't, it'll hold sand with some what do you call it? Styrofoam, just to get the weight right.
Ballast. You have a ballast weight. Where does this payload mount in the rocket, and how is it
In
mounted?
the forward tube, about under the nose cone, under the shoulder.
So it's in the forward tube and attached to the forward tube, or it's in the nose
It's
cone?
attached on a bulkhead from the bottom, and we'll have all threads coming through here. I don't know if you can see that.
Yeah, I think, yeah, it goes up the side of it.
Yeah, and then we'll have some cross bones up here, made out of aluminum, just to hold everything down. Make sure we don't crash into telemetry like last year. It's my fault that they broke their big red beam. So we're trying to mitigate that.
Gotcha.
Oh. And this is our payload bulkhead. It's pretty thick. It's made out of aluminum, and this is right above the main.
It connects to the main.
It connects to the main parachute.
Okay, so the main parachute's connected to that, and then your payload is above it.
Yeah,
Yes.
it's gonna sit here.
Got it. And then all of that's bolted together, and so
Using
when
an alt thread, yeah. We're gonna have alt threads coming through on these holes, and that's gonna hold me down up here.
Okay.
With some crossbones up top.
all right,
Any questions for payload?
you got washers on your nuts on your bulkhead?
Always, yes. Anything
Oh, we
else?
didn't ask about rail buttons.
Not yet.
Okay.
I think I saw them on that picture of the rocket. Where are they located?
Right there where that line is, that's where they're located. But we got it here.
We got it right here.
There's one right here, and the other one's up here.
So this bottom rail button is 3 inches from the bottom, from the aft end of the tube.
Okay.
And then we have our forward rail button. Was it 40, 30?
No, 38.
38 inches from the bottom.
All right. So what's the effective length of your rail?
That would be between. Well, I designed it to go with the 17-foot rail.
But with your rail
these
buttons, yeah, what I'm asking you is the effective length of the rail, because you don't get all 17 feet with the way the rail buttons are mounted, right?
Right. So then this
You
would
lose stability at what length?
Oh, where is it? I think it's 10. I would have to double check on that. I don't have that.
Okay, well, it's the whatever the length between your rail buttons is, right?
The length.
When the top rail button leaves the rail is no longer providing you any significant stability.
So this distance between is there a measurement tape?
So that's important to know when you do your simulation.
Okay. We'll get that for you real quick. Let's just get a measuring tape.
Well, he said it was like 40 inches or something like that.
38, I think, on the top button. 38
Yeah,
from
so,
the
okay,
bottom.
so 3.5 feet.
And how many is the bottom one from the bottom?
3 inches from the bottom,
And this one's 38 from the bottom.
and let's double check that.
What you
38
care
minus
about
3.
is the distance between the two buttons.
So that would be 38 minus 3, 35 inches.
All right.
We'll
So,
get you an accurate number.
so you take that distance and you subtract it from your total rail length.
That would be
32. 32.
2 minus 32 inches.
How many inches?
32 inches.
It's 172. Well, minus. It's a ratio, or what are you looking for?
It's minus the rail length.
You just you
We want
take the rail length and you deduct your rail button distance from the total rail length.
That would be 172 inches.
172.
You got 172 inches.
But did you understand why this is important?
Yeah.
Yes.
Okay. And then it's important to then make sure that your simulation calculations and data reflect that. You have a piece of metal that's 17 feet long,
Mhm.
but both rail buttons will not be engaged in that for the full 17 feet.
Yes.
You guys have a big motor. You got a lot of thrust to weight ratio. I'm not really that worried about it, but it's important to think these things through, just so you understand the implications of rail buttons that are far, far apart, end up not providing you, the rail effectively becomes a lot shorter. Okay.
Okay.
Yes.
Okay. Makes sense.
All right. What are the did you purchase them or did you manufacture them?
We've purchased them. They're the 1515,
Okay.
1.5 inches, and they're the airfoiled ones that we have.
Have you tested them on a rail? Have you run a rail across it?
Yes, we have.
All right.
Okay.
I'm good on rail buttons. Andy, you good?
Good.
All right. Let's move on.
All right. Flight predictions. Okay. So, yes, so we'll keep that in mind with the effective rail length. As far as the data that we did have, so liftoff weight, thrust to weight ratio, 10-1. Launch rail departure velocity, I've been trying to keep this as much as I can above 100. I know that's important. So we're balancing between 102 to 104. And here we have our flight graphic as well, and just a little in depth into the flight. Maximum velocity, 908 feet per second. Predicted apogee is 9,741. We're looking to polish the rocket as much as we can to get it with a real nice finish and bring that projected apogee up as much as we can. I know there's some give that Open Rocket has, but we do want to make sure that we're in that range to have an effective apogee.
Well, you're dependent upon wind, right? Both
Yes.
lower winds and upper winds.
Yes. So most of these simulations that I've ran them with 5 miles per hour and 10 to 15 miles per hour. And so the best simulations that I've gotten so far within the 10 mile per hour range, I mean, it's going to be better at 5, but with 10 miles per hour was, I guess, the standard that Open Rocket has. We've been projecting numbers similar to this.
Okay.
And so maximum accelerations, 11.3 Gs, and minimum static margin off the rail during boost is 2.12.
All right.
And then,
What is so feet per second? Are you above or below Mach?
We are slightly below Mach. Yes.
Okay. Where's the Mach threshold? Do you know
It is. We have.
how many feet per second?
I believe it's is it 1,000 feet per second? Is it 1,000 feet per second?
It's usually about 1050.
1050. Yes, so we're below Mach. We're about, I think it's 0.82, 0.8, 0.85.
Okay.
So
All right. So yeah, let's go. Let me look at your drogue. I want to see your main deployment altitude. Do you have it here?
Sure. Main deployment.
Back one slide. Yeah, back one slide.
Let's see. We are
1,300 feet.
1,300 feet.
What's
Yes.
the diameter of your parachute?
Our diameter for the main is 9 feet.
9 feet. 1,300. And when's the backup charge?
I'm sorry?
So you're gonna have your primary charge at 1,300 feet.
Yes.
What is
The
your
backup charge would be 1,000 feet.
1,000? All right.
So our descent rate for the main would be 20 to 22 feet per second. It's been bouncing around there. And our drogue descent rate is pretty high. It's 96 feet per second. But we are a lot heavier as a rocket in general.
Okay. Can I see that? Do you have the drogue chute handy?
We do not have the drogue. We have our previous drogue chute. Our current one is being manufactured with Rocket Man. So we're waiting to get them in the mail. Yes.
When was the last time you spoke to him?
A couple weeks ago. So
Guys, you are less than a month.
less than a month away.
Less than a month away. Plus, you have to pack all this stuff up, a week before. So,
Yes.
I would be hot on his backside to get that thing shipped.
How are you going to test this
Yes.
weekend if you don't have the drogue chute?
So we do have backup chutes. We do have a sky angle drogue chute that we've used on our previous build, and we do have a backup sky angle as well. And then we're also going to be getting a backup main as well.
Have you done a
previous-
simulation on your sky angles? What's the descent rate?
So the descent rate on the sky angles, I believe that was, I want to say it was the descent rate on the main or the drogue.
No, the drogues.
The drogue, I want to say it's been. I don't have the offhand, but I believe we were around 60 to 70.
Oh, it's a big
3%.
drogue. It's a big drogue, huh?
Yeah.
Okay.
Well, I believe the sky angle is 32 inches. And the Rocket Man one will be 24 in diameter.
Gotcha. All right. Well, again, from a ground testing perspective,
Mhm.
make sure. So I have seen a number of videos that other teams have sent, and I've seen other people do this where they ground test, and all they've done is stuck the nose cone on the thing and they fire a black powder charge and see if it breaks the shear pins, right?
Mhm.
And that is not an accurate test at all for what you need. You need to have it fully packed with the parachute or similar, with a flame bag and all of the shock cord, not a shortened one, right? All of the things need to be in there when you do the ground test so that you get an accurate depiction of how it's going to behave.
Plus, you need the experience of packing all that stuff up anyways.
Yes.
You don't want to be out there for the first time packing a big chute and find out, wow, it's not enough space inside the rocket.
It doesn't fit. Yeah. It's so tight that my shear pins are going to pop up open,
Yep.
Right. Yeah. So as I mentioned, we were doing a lot of deployment testing on our previous vehicle just to kind of test things out and see what goes wrong. So we did extensive testing and tried different shear pin numbers and to see, what would work, what couldn't work, if it was over engineered. And we did, when we would do these tests, we would load everything up on there.
Okay.
We actually deformed the old coupler as of all our deployment testing. So
Oh, wow.
this week we're going to be pretty heavy on this. So
Okay. All right.
and
I'm not I'm not particularly concerned. Some people go a little bit higher with their mains, depending on their descent rates, but 1,300 feet will give it enough time for that size parachute to inflate. So I'm okay with that.
Yeah, that was something that we were bouncing back on for a little while. We didn't deploy the main last year, so we were going to shoot to 1,500 feet, but I think 13 is a little more reasonable in that
Well,
sense.
yeah, a 9-foot parachute will inflate. If you get bigger parachutes, the bigger they get, the longer they can take to inflate. If you don't have deployment bags and a drogue to pull that to help inflate the parachute, right?
Mhm. Okay.
Okay.
And then vehicle overview, just a little more information about it. And we also have a simulation that I ran for this presentation. So this is the current vehicle that we have right now. We're deploying around 99,740 around there. And that was for a drogue. And then our main deployed at roughly 1,300 feet. Right there. So vehicle length 123 inches. Our diameter, we increased it from 6 inches last year to 6.53 because we used a PVC mandrel along with mylar and lithium grease to remove the body tube off. And so it's cheap. You can get it at Lowe's. So it's it worked for us really well.
Okay.
And so our vehicle weight currently on the pad, it will be roughly 75 pounds with motor and everything else deployed in it. Dry would be around 64 pounds.
So have you fully assembled the rocket and weighed?
So we've assembled everything besides 3/4 of it at most.
All right.
We're waiting for the nose cone to put it on there, and then also the tip and mount and just forward. So
All right. Well, that was the piece I alluded to at the very beginning, which is
Mhm.
your simulation. You need accurate inputs to get accurate outputs, right?
right,
And the best thing to do is have a fully assembled rocket. And then the next best thing to do is to have a fully assembled rocket with a motor.
right,
Right. Now you can take and weigh your grains of your motor and create a ballast or something to get a pretty accurate, because one of the things we're going to ask you to do is the balance beam test, right?
Mhm.
Show us center of gravity, not where you think it is, but where it really is, right?
right, exactly.
Rocket's assembled and ready to fly. Put it on a balance beam and show me where that center of gravity really is in relation to center of pressure.
Okay. Yes. So we should be assembling that tomorrow for deployment testing. Get everything on there, and I can send you videos of that as well, so you can see how it goes, both of you all.
Well, I'm
And,
telling you guys, you need to know this information so that it's more important for you to know, because if you need to make an adjustment, right?
Absolutely. Mhm.
Okay.
Absolutely. I've been trying my best to weigh everything that we have. I've been
Yeah.
putting the epoxy components, everything on there.
Okay.
So
Excellent.
yeah, and then we
Oh,
have
wait. No. Okay. And there's the.
just an overview of our open rocket here. How it's
Okay. Yeah. I see the bulkhead now. And I see you've got. So the nose cone is bolted on and it stays fixed up there at the top, and the tube comes off of
the cup.
The cup. Okay. All right.
So current stability is 2.67 calipers. That's currently what we're looking at. And then we also have pretty much all our parts that we have built so far. If you all want to see more in depth into how we built those and how we have them here.
You guys have done a pretty good job in that fin can. I'm impressed. That's pretty. I mean, you paid for it in weight, but that sounds pretty beefy.
Yes. It's very stiff. Very, very.
And it's a 4-fin design, yeah. Okay.
Yes, sir.
I don't know, Andy. I don't have any other questions. I don't think. Let me look at my cheat sheet.
No, honestly, I'm pretty impressed. I'm
Yeah.
I'm excited to see the test flight. I know you guys have struggled to try to get a successful recovery, but the test flight will certainly help that, I think. So, very exciting. I think we've had your team up to the Tripoli Houston area for a couple of attempted launches, that kind of stuff as well in the past. So, again, I'm excited to hear how that. I won't be able to make the shootout this year. I was fully planning on doing it, but we had a little issue with the family. So, anyways, you guys have fun out there. Let's see. I wanted to chat real quick, if you guys have a free 10, 15 minutes, about general logistics of the Cup. So a couple of things that I wanted to ask. How many people from the team are attending?
So we'll be taking 13 people.
Okay, so we got 13 folks. Not a horribly long drive, but still a fairly decent drive from down South Texas area. You guys staying in a hotel, Airbnb, or the dorms?
We'll be staying at an Airbnb on the north side of Las Cruces.
Okay, very good. Are all 13 people staying in the same house?
Yes, we'll all be staying in the same place.
All
That's a
right,
lot.
so no, I understand
Yeah.
that completely. Just
We
You
won't
know-
tell the Airbnb people.
no, I
You know, we
understand.
were actually planning on 15, but I think we shortened it down to 13, just a little more easier to accommodate that many people.
Copy that. So, a couple more questions. Liability waivers. If you guys have been there in the past, liability waivers are critical. Those need to be completed by everyone, including your flyer of record and any advisors, faculty members, et cetera, that are coming. So that if you haven't already done it, it's at spaceportamericancup.com, right at the very top. It just says liability waiver. Click on it, have each individual fill it out themselves, and hold on to the email. It should send you an email because that way when you're checking in, you just show them that email and you're done. If you can't show them the email, you can't come up with proof that you did the liability waiver, you likely will get the opportunity to do it again right there, which will hold up everything. Next thing is proof of Tripoli memberships.
Yes.
So all the folks that are going for recovery or out to the pad or anybody intending to go downrange, you will need your Tripoli membership. I don't think they're sending out cards anymore, but they're sending you like a digital membership card. You need to have that available as well. Esther will likely send out an email survey similar to the one you guys already filled out. That'll just say, all right, final check. Give me all the names of everybody that's coming, Tripoli ID numbers, and confirmation that they filled out the waiver. Maybe a couple other questions here and there, but nonetheless, it'll be basically a copy of what you'd done the first time, but we need those numbers to make registration go a little bit smoother. Last year's registration, not smooth.
Yes.
I can attest to that because I helped do the registration.
Yeah, exactly. Yeah, Chris, you were right in the nightmarish side of it. So, but this year it'll be better, quote unquote. Hey, that's the Esra mottos. Next year will be better.
Oops.
All right, so very good. So, how many people on the team that are attending this year attended last year?
I believe only about 4 or 5.
Okay, but at least
Yes.
there are enough to sort of explain the general process. A couple of things that are definitely changing that everyone needs to be aware of. Please stay on top of your Hero X updates. Super critical. How many people receive the Hero X updates on your team?
Believe our leads and captains receive the updates.
All right, very good. If I get to a team that has just the team captain is on Hero X, I get real freaked out because that's where a lot of lost communications occur. Maps. The 4 or 5 that have been there before likely should remember pretty quickly the process and path for getting there. Do not rely on Google Maps. You will end up on a goat path on the wrong side of a mountain. Yeah,
Literally.
Google, Apple Maps, all of that are going to be nasty. So if you click on resources on the Hero X website, there is a link in there for maps. It is a corrected Google version of the maps, and it has both from Truth or Consequences, which you won't have to worry about, as well as from Las Cruces. and it'll tell you exactly drive this many miles down this road. You'll run into a turn on this exit. It'll give you all the details of how to get there quickly and safely. The new road that goes out there, it's 45 miles per hour. And trust me, I'm one of the worst ones. I just cannot go. I mean, I'm from Houston. We don't go 45 miles an hour. We just don't. But I guarantee you during the cup, there's going to be state troopers. There will be county constables. There'll be all sorts of stuff sneaking and hiding around corners and stuff. So don't be the guy that got a speeding ticket.
Over the hills. The road is pretty
yeah.
straight, but there's these little hills.
Yep.
And they'll be just below the hill out there generating as much revenue as they possibly can.
And last year, one of the, I call it a blankety blank police officer, he just parked the car right over the hill and then left the car empty. So I'm over the car, over the hill, 65 mile an hour. I'm like, what? And I just pulled over because I knew he was going to pull out and get me. And he never pulled out, so I pulled back onto the road. But again, don't be like me. Be careful out there. If you can, just get a guy in front of you that going real fast and just stay like that. Try to get there early, obviously. Gates will not open until 6 a.m. this year. Integrated master schedule is in your documents website, where all your critical documents. Print that out, not now, not next week. Wait until the week before, just in case we make any changes. Print that thing out and set it up. Put reminders on your calendar. It is very important. Registration opens up at this point in time. It closes at this point in time. It'll tell you that Monday is team picture day. Okay, so the team will have team pictures like last year on Monday. So if you show up looking like you just rolled in, out of a dust storm, those team pictures not going to look real exciting. So again, wear your shirts. If you got team shirts, always cool. The mass picture, the large every team picture is now on Monday. So it'll be Monday at the end of the day. So if you finish up registration, you finish up setting up your table, don't leave. You got the 5 o'clock photo shoot to hit that big one. Now Tuesday we're going to have to close it. We're going to shut down about 4:30 at the convention. They have a huge event that they have to prep for, and we've got to get out of there pretty quickly. It'll be similar to last year. You can pull up on Monday and back up to the loading dock and unload all your gear, and then pull your vehicle out. You're going to have to park in that parking lot that's like 2 blocks away. But you can pull into the parking lot to unload and then pull out. If you happen to find a spot in that parking lot, great. But a lot of those are reserved for staff. So I'm trying to run through anything else that might be really critical. We already talked about the liability waivers, membership info, all that kind of stuff. Please, Tuesday evenings, Wednesday evenings, all that kind of stuff. Let's say, for instance, you guys are lucky enough to launch on Wednesday and everything's great. You got 3 or 4 days to party. That's great. Don't get in trouble. Please, dear God, do not let me get another phone call at 3 a.m. in the morning about a girlfriend, boyfriend broke up and the girl wants to kill herself. And I can't deal with any more of that. Please keep your drama mellow. Right. Keep your, whatever you're going to do, just don't take it to a level that you're going to embarrass yourself, you're going to embarrass your school, or you're, worst of all, embarrass the SRO and Spaceport America Cup. Same thing with driving. By gosh, if you're drinking, you better not be driving. That's a quick way to get yourself permanently banned. So again, have fun. Go visit the city, go spend money. We're going to have a swag shop. So instead of just getting your normal T-shirts and a couple of stickers and patches, and there you go. You're definitely getting those. And I fought hard for those. They wanted to say that students wouldn't get those this year.
What?
And I'm like, you just raised how much they pay, and now we're going to. So I won. Thank God, I won. But nonetheless, there will be a swag store. So let me show you some of the new swag. Chris, this will be new for you too, buddy. This is a test cup. But I've got some laser engraving going on.
Oh,
Facebook
wow.
American Cup and Esther and that kind of stuff. I mean, we'll have tons of stuff, but we've been working on that real hard for a while. The live stream, definitely having a
Yes.
cool live stream, even better than last year's. So we want personalization. We want to know that, hey, UTRGV is up on the pads. You know, if you have a team introduction video that's 15 seconds saying, hey, here's our team, here's our rocket, here's what we do, here's some details about the rocket, that's great. Or if you want another one that said, you know, here's the team leads, you know, the president, the engine, just make it quick. I mean,
Sure.
you've got about 15 seconds to do that. And then if you want to make a longer one, that's great too. You know, make us a 30-second one, because last year the chief complaint on the live stream was too much dead air. And so we want to try to fill it up with those. And, you know, who knows? You guys could win it all. And then we've got great videos that we can say, and for the winner of the 2023 Spaceport America Cup, and then we play your video. Wouldn't that be cool? Because the closing
Yes,
ceremony
that would
is
be
going,
nice.
it's going to be at the Pan American Center, not at the convention center. So it's not going to be elbows and butt cheeks and that kind of stuff. It's going to be in a basketball arena with a huge, you know, one of those video things on the top.
Jumbotron type of.
Jumbotron, yeah, all that kind of
Nice.
stuff. So, and that'll be live streamed as well. So again, pretty important from all of that standpoint.
Question.
Yes, sir.
How far is the Pan American Arena from the convention center?
Oh, it's all part of New Mexico State University, so it's all within blocks.
Okay.
Yeah, yeah. If you can get to the convention center, the Pan American Center is right around the corner.
For you young kids, it's walking distance.
Yeah.
It's cool.
So again, any type of questions, concerns, whatever that you might have, you definitely need to have the you know, bring it up to any blue shirt while you're there.
Okay.
Emergency after hours stuff, we will have contact information for you. I think you guys have probably seen emails from me, you know, 1,000-fold over. That always has my cell phone in it. So you can definitely call me. You know, again, scenarios like, hey, we just had a major disaster and we're packing up tonight and leaving. Okay, we need to know that. When a whole team just disappears on us, we kind of freak out a little bit. So please keep the communications going. If anything, talk to your flyer of record, talk to your safety reviewer, whatever you need, but keep the communications going. You know, as well as anybody with the experience, you've been there, launch early. The
Yes.
winds in the morning are nice. The winds in the afternoon, not so nice. We had
Hopefully
rain.
no rain too.
We had rain last year, obviously, and they have already had a couple of torrential downpours there,
No.
which is even, you know, it could be potentially the beginning of their monsoon, which would be horrible, but we're monitoring it pretty closely. But 2 days ago they had a very significant downpour, first one of the year. So that's not a good sign, because it just seems like the monsoons are coming earlier and earlier. So
Yep.
usually they don't happen until well into July. So, but we'll have to deal with that. You guys understand about bringing your own stuff, your canopies, your chairs, all of that kind of stuff. Do you guys bring a trailer, or do you have everything loaded in vehicles?
So we'll be loading in vehicles. Yes.
All right, so the vehicles will need to be unloaded and then parked in the parking spot. You'll have a 20-foot by 20-foot, similar to last year. You know, when you're done flying, help out other teams if you can. You know, good sportsmanship never hurts. If you need something, you've got 100+ other teams that are out there. So here are the numbers I'm looking at right now. This is potentially going to be a record year. I'm looking at about 1,800 students and potentially 120 to 126 teams ish, somewhere around there. So if you thought that it was really packed in the convention center last year, it's going to be max capacity without a doubt. And they still want to try to get it to 150 teams. But nonetheless, going to be very packed on Tuesday. Once we get out to the pads, it'll be good. I think that is it. Any other questions for me?
Is GoPro going to be there?
Yeah, they will not. First year in many years. They've never wanted to be a premier sponsor, you know, really get big into it. And sometimes I think the US guys from GoPro are like a bunch of freaking teenagers. They are all over the place, and trying to get a hold of them and pin them down to anything has been ridiculous. They're going to ship us a bunch of cameras, but that's about it. And none of the cameras we can give away, and none of the really good ones. I mean, these will be mixtures of probably 7s, 8s, and 10s, I guess. But no, nothing from the video challenge. We'll still have the video challenge. So if you are trying to do any type of live video from the rocket, but I am letting you know next year, the video challenge, I'm not going to say it's a requirement, but you're going to get bonus points for it, because we cannot get students to put video on their camera. And I don't care about video live, coming back to somebody watching it on a screen. Just recorded video from your rocket, from the flight. That stuff is so cool, and nobody does it. Literally nobody does it. So next year it might be 50 or 100 points, bonus points, just to turn in your video. So start planning for doing that next year. I think that's it. Anything else?
What's the standing on generators out at the launch site? Are they allowed? What are the safety precautions you guys have on those? I know the noise was a thing and all that.
Yeah. So generators, small generators are allowed. And when I say small, I mean if you show up with a 9,000 watt, diesel, 4-cylinder, whatever, no, it's bad. If you've got, a little Predator 2,000 watt that's, just there to run, a couple of your electronic pieces, that's perfectly okay. Running it nonstop all day, every day, bad. I'm sorry, you cannot run an air conditioner out there. If you need it for soldering, if you need it to run some of your electronics, that's okay. But I don't want to hear about generators going all day long out there.
Okay.
Okay.
Fair enough. Any other questions, guys?
Yeah, good.
I think that's
All right.
about it.
When was the last time you talked to your flyer of record?
Last week, 2 weeks ago, I believe. Yeah, 2 weeks ago.
Keep him in the loop. If he's got any concerns,
Mhm.
and he can pull his name off that list anytime he wants to. If he doesn't feel comfortable with your rocket, he can just I'm done. And if he does that, it's not going to be a good day for you guys.
Sure.
Because y'all are going to come to me saying, "We need a flyer record."
We've been pretty open about everything that we've been doing, and we've been using some of his methods as well, in terms of the fillets. So he has no concerns so far.
Excellent.
Awesome. He's going to be there at the shootout?
He will not be there for the shootout. Peter will be our L3 for the shootout.
Okay.
Oh God, Peter's coming to the shootout.
Yep.
Oh, by the way, I just want to let you know, Peter Tarl drives me nuts. Oh my God, he's like Stewie, like Stewie. He just runs around and just annoys me. Brilliant guy, without a doubt, but just he can turn around and say something really brilliant, and then start doing donuts in the Spaceport America parking lot.
Sounds about right. Yeah.
And Chris, you laugh. He actually did.
Oh, I was a Marine. I have seen many stupid things out of grown individuals that should know better. So
yeah. So, anyways, that's it from you guys. Thank you. Good review. Looking forward to it. And I hope this time is a good time for you. I hope we get 100% great recovery. And I want to see you guys coming back from the. I'll be helping out in the recovery data tent. So I want to see a beautiful rocket and pull lots of great data off of it. Please practice pulling data off of your rocket. This year we will listen to beeps. Okay, so you can Stratologger. I know all about Stratologger, but have your laptop, have your cables, have everything ready to go, and bring your whole rocket with you. Okay, and so we'll download the data, just do a quick compare. Hopefully it won't take more than 5 or 10 minutes from that standpoint. We're not going to do a compare and contrast between 3 or 4 different, we're going to look at your either prime, whatever your COTS altimeter is, we're going to pull that data, and that's going to be your data.
Sure.
So, a lot of teams like, no, that's a terrible one. Don't do that one, do this one. And then try to average it. And, they're clearly just we have to stick to the commercial standardized altimeters, and that's going to be the case. And if I have to just listen to beeps, then I'll listen to beeps. So that'll make it quick and easy.
Okay.
All right, guys. Thank you
Fair
much.
enough.
Thanks,
Thank
Dan.
you.
Thanks,
Take
guys.
care.
Oh, send me the recording too. Okay.
Okay.
All right. Thank you much.
See you guys.
Thank you.
Thank you.
Bye.